The first thing is, why do we do this webinar? For who? What are we going to present? And so on. Simply because SysML is the most largely used language for systems modeling. And the question of the positioning of Capella with regard to SysML is a recurrent one. We are asked questions about how does Capella relate to SysML. For who do we do this webinar? Primarily for people considering using Capella, but having second thoughts about it because Capella is not SysML. So we want to try and explain clearly what the positioning is. For people who do not have an extensive knowledge of either SysML or Arcadia Capella, that means what I'm going to talk about today is not a deep dive into the specifics of the language of SysML, nor in the implementation of Capella, but just mainly a mapping of diagrams and how things are a little bit different in both approaches. But it's also targeted to SysML experts who are curious about our approach or who are questioning our approach. And as you will see, we are open to discussions. So what will be covered in this webinar? The first thing is a high-level positioning of SysML on one side and Arcadia Capella on the other side. I will talk about the diagram equivalences and similarities. I will focus on what we think are the three main differences between the two approaches. And at the end of the webinar, I would just give a quick tooling perspective, explaining why the Arcadia method is not a SysML profile. What is not going to be covered in this webinar? So the details of the Arcadia engineering method. We have had several webinars on this topic. The details of how Capella is different, or what are the added value of Capella and so on. We've also had dedicated webinars, so I'm not going to elaborate on that. I'm not going to talk about expert-level technical analysis of the SysML language, but of course, I am happy to engage technical discussions on this topic, but outside the webinar context. So first of all, a disclaimer. I don't pretend to be a SysML expert, so there are things that I'm going to say that are maybe wrong, and in that case, I'll be happily corrected. The fact that we chose for the Arcadia method not to rely on SysML is just our choice, and we are trying to explain it in this webinar. Quickly, just to be sure everybody knows what we're talking about, I said I wouldn't do a deep dive into Arcadia, and I would just focus on an overview. So Arcadia is an engineering method for model-based systems engineering. It tries to enforce a clear separation between context and need modeling and solution modeling. So it is intended to provide guidance for systems engineers in order to design their architectures. So the primary goal of Arcadia is to provide means to build architectural designs, to evaluate architectures, to prepare the subcontracting to the downstream engineering teams, and basically to secure the technical contracts that we have with the downstream engineering teams. Arcadia is mainly about performing functional analysis, identifying subsystems, identifying the interfaces between subsystems, and justifying these interfaces with functional content. And then we'll see that Arcadia provides means to evaluate the architecture according to different perspectives. The concepts of the Arcadia method, this is just a simple extract, but to give you an idea, we have about 12 similar views covering most of the concepts of the method. So for example, here we say that a function can be part of a functional chain that illustrates system capability and so on. So it's pretty basic, pretty simple, and with 12 similar views, we are able to basically cover all the fundamentals of the method, and so on. I believe in English language you say that you can compare apples to oranges when you don't talk about the same topic. In French, we have more or less the same, but we say that we shouldn't compare cabbages and carrots. And this is basically what I am doing here, because on one side I have SysML, which is a language, and on the other side I have Arcadia and Capella, which are a method and a supporting tool. So comparing the two is really a difficult exercise, but as the question is really asked really often, well, we try to do it anyway, even if we compare apples and oranges. So SysML is a general purpose modeling language. It has a broad spectrum of application, and it has rich and advanced expressiveness. On the other side, Arcadia and Capella are primarily dedicated to architectural design, so identification of functions, structure, interfaces. And one of the goals of Arcadia and Capella is really to aim at an easier learning curve for systems engineers. There's no method provided by SysML because it is just a language, but SysML is compatible with several methods. Arcadia Capella, on its side, as I just presented, enforces or tries to enforce a separation between context, the need modeling, and solution modeling, and has a few other guidance embedded. And then the language. So SysML is an extension of the UML language, which is based on software-generated paradigm. On Arcadia and Capella, about 75% of the concepts that we use in Arcadia and Capella come, or at least are similar to SysML ones. We are also using some NATO architecture frameworks concepts. But basically what we're trying to do is to simplify and enrich this language to better match the concepts that our systems engineers already exploit in their current practices, and for example, functional analysis. I will now start the section that presents the similarities and the equivalences between diagrams in SysML and diagrams in Capella. So I call them the twin diagrams. And to do so, I am using a very simple camera model that was first used by Sandy Friedenthal, who is in charge of the SysML v2 RFP, and now in charge of the SSD submission team for SysML v2. And he started to use this model to illustrate the integration between behavior and structure. As I was participating to the working group, I also used this model to present the working group, the SysML v2 working group, the feedback of Arcadia and Capella, and using the same model. And this is the model that I am using today. Okay, so let's start with the block definition diagram. So the block definition diagram in SysML captures the definition of the blocks in terms of properties and operations, as well as the relationships between the blocks and the interfaces that are provided and required by the port. The block definition diagram is a redefinition of the UML class diagram. In Capella, blocks are called components. We have two kinds of diagrams that we position in front of BDDs, so block definition diagram. The first one is the component breakdown diagram, which is a tree on the bottom right. And the other one is the component interfaces diagram. On component interfaces diagram, we don't display the properties of the components, and the composition is not represented with links and diamonds and arrows and the typical things that we find in the BDDs, but the composition is represented by graphical containment. So that means on this diagram, the shutter sensor is part of the motherboard. And what we see here that components in Capella have ports, flow ports or standard ports, and provide or request interfaces. The next diagram is the internal block diagram. So the internal block diagram, or IBD in SysML, captures the internal structure of a block in terms of properties and connectors between these properties. So in this view, we see that the motherboard contains the image processor, which is connected to the sensor, which is itself connected to the image controller, and so on. In Capella, the architecture diagram is really similar. It describes the assembly of components in terms of internal breakdown. So we once again see the containment represented by graphical containers, and we see the same connections between the different components. We have the delegation mechanisms and so on. So when it comes to IBDs, it is really pretty similar. The next one is one of the trickiest one in terms of mapping. So it's activity diagrams. Activity diagrams in SysML represent the flow of control and objects between actions describing activities. So what we see on this view is a set of actions that together illustrate one given or define one given activity. And between these actions, we can have control flows or object flows that illustrate the dependencies between two actions. These actions are allocated to partitions that are represented by blocks. In Capella, the equivalent of activities and actions are functions. This is at least what makes the most sense in terms of semantics, because functions are verbs. They illustrate what the components do. But in data flow diagrams in Capella, we only present the dependencies between the function with no semantics of control. Allocating functions to components in Capella is actually pretty similar to allocating actions to partitions in activity diagrams. And on this diagram, I really voluntarily presented my components in a vertical layout to illustrate that this is really pretty similar to swim lanes. I will come back on activity diagrams in the differences, in the part that describes the differences. Sequence diagram. Sequence diagrams in SysML describes the interactions with a focus on the time sequence. So what we see on the sequence diagram is a set of lifelines in which we have messages that are connected to operations that are provided by the blocks representing the partitions, the lifelines. We also have constructs like parallel, loops, alternatives, and so on. In Capella, we rely on the exact same underlying constructs as SysML. So it's basically a one-to-one mapping. The main difference resides in the variety of elements that can be referenced in a consistent manner by lifeline and sequence messages. So what you see on this example is components in lifelines, and the sequence messages are actually what would be object flows in activity diagrams. The green boxes that you see are functions, so functions that are allocated to components, equivalent to activities or actions. Time-ordered presentation of activity diagrams in sequence diagram, kind of. But this is only one type of sequence diagram in Capella. We can, for example, represent the functions directly in the lifelines. So what we see here would be equivalent to activities or actions represented by lifelines. The sequence messages are what we call functional exchanges, data dependencies, or physical flows between functions. We can also have a simple operation-based scenario, and these are operations that are provided by, well, that belongs to interfaces that are provided or required by components. So really, we have a large spectrum of usage of sequence diagrams. State machine diagrams. So a state machine diagram in SysML describes the state transitions and actions that a system or its parts perform in response to events. So if we take the example of the camera, we have a state that is shooting, and this the state as substates which are focusing, processing, focused, and between these states we have transitions that are triggered by events, and so on. We use the exact underlying, identical underlying constructs in Capella, but we add a little bit of semantics. So we make a difference between states and modes. And here, I want to use state machines to illustrate what we mean usually by when we say simplifying SysML. So on the left side, you have what you find in a typical SysML tool, here Magic Draw, and on the right side, what we have in Capella. In SysML, there's a really rich expressiveness, and when you try to specify the entry, for example, of a state, you have several choices, and you have to pick up between different kinds of elements, so activity, function behavior, interaction, opaque behavior, protocol state machines, and so on. The same for trigger, where you have other choices, of course. We know that our systems engineers are not able or are not willing to or don't need to understand all the differences between the different options that would be presented in SysML. In the state machines of Capella, a trigger is either a function, a dependency between two functions, or an operation. An entry is either an operation or a function. The end user doesn't have doesn't have more choices than this to do. It doesn't have the choice. So the expressiveness is limited compared to SysML, but it fits, once again, the objective of Arcadia, which is to design architectures and not necessarily to perform low-level modeling of system components or so on. So this is what we mean when we say we try to simplify SysML. It means we try to hide some of the expressiveness that comes with SysML. And I do that on a state machine, but I could do it on activity diagrams, and I could do it on other parts of SysML. And once again, it doesn't mean that this expressiveness in SysML is not useful in other contexts. Use case diagram. A use case diagram in SysML is a high-level description of functionalities that are achieved through interactions between a certain amount of system and actors. So here we have several use cases, take pictures, that include another one, like take picture in a studio, and so on. We have the exact same thing in Capella. The difference is use cases are called capabilities. They have precondition, postconditions. They are illustrated by sequence diagrams, functional chains, and so on. So it's pretty similar. The next one is the requirement diagram. The requirement diagram in SysML captures the requirements hierarchies, as well as the traceability relationships between the requirements and the model elements. So this is a specific diagram in SysML that allows to do that. In Capella, there is no dedicated requirement diagram, but all requirements and their relationships can be displayed in any Capella diagram. That means you could display the requirements in a data flow diagram, an architecture diagram, a sequence diagram, and so on. So it's something that is generic to all Capella diagrams. Parametric diagram. Parametric diagrams in SysML show the use of constraint blocks with the properties they constrain to specify equations. So here, for example, we compute the hyperfocal distance by a formula that uses some of the properties of the sensor and the optical assembly. We do not have a dedicated parametric diagram in Capella. We have several means to specify constraints with equations. Parametric diagram would be an easy addition to Capella if our end users were requesting them, which hasn't been the case so far. So I illustrated on this diagram the simple use of a constraint to input a formula, knowing that in this formula, Capella provides a mean to have a real reference towards the property, and it's not just something that is textual. What we cannot do here is to chain the different constraints or the different equations in a bigger diagram. So once again, that could be developed if ever it was needed. Now, I will talk about the differences. So the first one of the differences is the way functional analysis is supported in Capella. And for that, I come back to SysML activity diagrams. Well, an activity is described by several kinds of actions. We can have opaque actions, code behavior actions, and so on. It is described by parameter nodes, which are the parameters of the activity. The parameters nodes are connected to action output or input pins, and there's a strong delegation mechanism. So what we see on this view is that the acquire image activity has three inputs, and these inputs are found on the specific activity diagram for this activity, and the same for these two other ones. So the handle user interaction and control the camera. Activity diagrams, as I said previously, have strong semantics of control, and they have control nodes are available, and there are control flows and object flows. In Capella, the philosophy is significantly different. So I already said that we focus on object flow, so the dependencies between functions, and we forget about control flows. But the bigger difference is that we don't use delegation mechanisms, and we use direct containment between functions. So we don't have equivalent of activity and actions, or actions that call activities. So it's the breakdown of a functional tree is really based on the containment between functions. In Capella, only the leaf functions are supposed to have incoming and outgoing exchanges. This means that the non-leaf functions are only grouping of functions. Several levels of functions can also be displayed in the same diagram, and I will illustrate that in the next slides. Because we don't have delegation mechanisms, we are able to, and because functions are only grouping of elements, we're able to compute simplified views. So the ports that you see here on control the camera, acquire image, and so on, are actually not the ports of these three functions. They are the ports of the children leaf functions of these ones. The fact that they are displayed here is just a graphical trick that allows to produce simplified views. And now I'm coming to the rationale for this. Well, first of all, functional analysis is a technique that is intensively used by our systems engineers, and they need to have multiple workflows. So the first one is simple workflow top-down. I create a few functions. I break them into sub-functions. So basically, I build my tree from top to bottom. In another use case, in another workflow, I have, for example, some existing documentation. I'm performing reverse engineering. I have a set of low-level functions, and I decide myself to do some grouping. So I'm just drag and dropping functions into one another. And what I'm doing here is that I build a functional tree, but from the bottom up. Another workflow is I am discussing with my client, and we use sequence diagram. We create functions on the fly, and at some point I end up with a set of low-level functions that I want to group, and once again in order to create a functional tree. And to support these different workflows, if we had to manage delegations between the different levels of functions, it would be a nightmare when we have 500 or 1,000 functions to maintain the consistency at all levels. This is why a strict rule in Capella is that only the leaf functions can have ports in a finalized design. So now I'm going to illustrate that. So this is what I have in my model: 2 functions with subfunctions, and F21, F22 having themselves subfunctions, and all the exchanges are between the leaf functions. So I will have that on the left side of the screen, and on the right side I'm going to illustrate what we can see in Capella when we remove some of the functions. So the first one is I remove the subfunctions of F21 and F22. Automatically the ports of these subfunctions are displayed on F21 and F22, even though they don't belong to these 2 functions. If I remove F21 and F22, automatically the ports are displayed on F2. If I do the same on the other side, then the ports are displayed on F1. So at no cost, I just generated a simplified view of my functional breakdown. The only thing is, now I am exposing all the low-level exchanges between these high-level functions. So we came up with another mechanism, a kind of tagging mechanism, where we can associate categories to functional exchanges, so data dependencies, and then compute simplifications based on these categories, this grouping of functional exchanges. So here, the displayed ports are not the real ones anymore. They are just ports that represent the different categories. So this is something that is pretty far from the way activity diagrams work in SysML, but it really covers a need of our systems engineers in terms of their traditional practices. So this was also demonstrated in the tool, in the webinar, how Capella is different. That is available from the Capella website. The next difference is the integration between functions, components, and interfaces. So I said that the Arcadia method is essentially about working on architectural design, and that means identifying the subsystems, identifying their interfaces, specifying the functional expectations for each of these subsystems, and so on. So we have a really strong focus on the consistency at all levels, meaning like at the functional level and structural level. So I already said functions have dependencies or functional exchanges. Functions have ports. Ports specify the expected or provided exchange items. Exchange items are sets of data or physical flows that are exchanged simultaneously, and functional exchange carry exchange items that are compatible with the source port and the target port. So here we just worked on the functional plan. Then we move to the connections between the components. So we move to the structural plan, and we're going to allocate our function ports to component ports, and to allocate the functional exchanges to component exchanges. The component ports that we see on these components provide and require interfaces, and the content of these interfaces is actually an aggregation of exchange items. And the exchange items that we find here in this interface are the exact same exchange items as the one that were carried by functional exchanges. This means that at the end of the day, when we see the interfaces between two components, we are able to justify the content of the interfaces with the functional exchanges between the components. So why do we have this operation and so on? And this is key in architectural design. Once again, this was demonstrated in the tool in the How Capella is Different webinar. By the way, talking about the integration between function, structure, and interfaces, this is one of the topics that is in the agenda of the SysML v2 SST submission team. And this is a topic I'm really interested in. Last of the three differences, the management of instances, or we could say definitions and usages. This is probably the trickiest one. In SysML, there's a block part paradigm. So basically, a block has parts are typed by other blocks. If I take the example of the camera has removable components, and the removable component block has two parts, so two slots that are both referencing the same block, which is memory card. And if I check in the component tree down there, I only have one memory card that I don't, which is here. So in Capella, we have this possibility to use the block part paradigm. But this is not the default setting of Capella. When you first install Capella and you launch it, this is not what you have. Because by default, we hide the concept of part. And we have reasons for that. We have two challenges. Or we had two challenges with regard to management of definitions and usages. The support of multiple workflows and the need for instances. Systems engineers are not necessarily software engineers. And systems engineers often think first in terms of instances, usages. And the modeling language or the modeling tool should not force them to think in terms of types first and then instantiate these types. So we need to have really flexible workflows where they can first create an instance and then make it a type and then instantiate it again and so on. That was the first challenge. The second one is architectural design in Capella often consists in performing non-functional analyses. For example, when we do safety analyses and so on, it is absolutely critical to distinguish between the different occurrences of each element. And this is true for components, for functions, but this is also true for the ports of the components, the ports of the functions, the component exchanges, and so on. We need to be able to associate different properties, different values to each unique instance of the elements. And what we see on the small scheme here is that we have two functional chains going through similar functions, but they are distinct. This was really difficult to achieve with what we found in SysML v1. So I'm not going to dive into the specifics of the language. I've tried to summarize on this slide my or our understanding. The thing is, in Capella, the definition and usage issue is not addressed by the language, it is addressed by the tool. So basically this means that the same concepts, functions, components, ports, can either be considered as types in some contexts and as instances in some others. And to be able to do that, we need some kind of model organization, and we need some tooling that allows to synchronize, to replicate contents and to synchronize it. And this is what we have in Capella. So When you open Capella and you try to do the same thing with a camera body and have removable components, you actually create two components, memory card 1, memory card 2. And we see these two memory cards in the component tree. These two components don't have to be created manually. Once we create the first one, we can use the replication mechanism to instantiate the second one, and they will be kept synchronized. So the solution that we have in Capella is called records and replica. And basically, a replica comply to records, and the compliance relationship between the replica and the records can be customized or can be different. We can have a black box compliance, meaning that the replica is strictly identical to the record, but we can have constrained reuse or inheritance, which all allow different kind of variation between the replica and the records. A record in Capella is not necessarily one component or one function. It is any set of elements, any closed set of elements. So it can be two functions with their exchanges. It can be one component with its functions. It can be a component with no functions, and so on. So there's no limit on what a record can be. So this is pretty useful, but it is not ideal in the sense that we would have liked to have a stronger conceptual foundation for all this. And this is what is missing in Capella, the fact that the same elements can either be types or instances is handy, but we wouldn't mind having a stronger conceptual foundation for that. So I went through the three main differences between SysML and the Capella implementation. So now that you've seen all this, that we've seen all the similarities between the diagrams in SysML and Capella, you could wonder why Capella is not just a SysML profile. There are several reasons for that. The first one is, about 10 years ago, we tried really hard. It wasn't with SysML, but it was with UML at that time, to develop our own profile with a lot of tooling associated to our profile and so on. And we struggled quite a bit because the tools at that point were not as good as they are right now. So basically, we were not able to hide the concepts that we didn't want our systems engineers to use. And when they were using these concepts, they were breaking the tools that we had developed. And when we had to implement things like the functional analysis and all the simplification mechanisms that I have explained, then we found limitations in the diagrams that we had to use in UML or SysML tools. So this is why we couldn't implement Capella as a SysML or UML profile. And there's another reason for that. It is because the tooling itself could have hidden some of the complexity of the language. But this is not enough, because the users need to exploit their models. They need to develop viewpoints. They need to develop validation rules. They want to perform queries. And when I say they want to perform queries, I'm talking really about the end user in front of his modeling tool. And if the method here, Arcadia, is logical components have functions, then the end user wants to do component.allocated functions and have the result. It was mapped on a profile, then the query would start to be, give me all the blocks with the component stereotype and give me the list of actions that have the function stereotype and so on. So basically, when we start exploiting the model, we don't hide the underlying complexity anymore. And this is really a strong reason why we also struggled with profiling. And that will explain some of our interests for the future. So, before leaving the floor to questions, I'm just going to say a few words about SysML v2, which is a really good initiative. The first thing is, I am, to some extent, participating to the SST SysML v2 submission team. Unfortunately, until now, I haven't managed to allocate enough time to this activity. It's not a lack of interest, it's a timing issue, but I try to follow at least what is going on in the team. And in particular, I'm interested in some specific topics like usage-based modeling, which basically corresponds to what we had in mind with instance first modeling, and I'm interested in interfaces and so on. The objective of our participation to the submission team is to provide feedback coming from Arcadia and Capella, coming from our experience, to the submission group. And this is what I did last year, for example, when I presented the integration between functions, component interfaces using the camera model. The goal is not necessarily to have Capella become a SysML v2 implementation in the future. I think the reasons why Capella is not SysML still stand. The reasons why it is a subset of SysML still stand, because the method is about architectural design and has a well-defined scope. But the ambition is really to seek an alignment on the core concepts in order to ease the interoperability. We are able today to perform exports from Capella to SysML, or with some constraint to import SysML into Capella. These are things that we have already done occasionally. We would like to have an alignment on the core concepts, and this includes, for example, the better conceptual foundation I was talking about regarding types and instances, or definition and usages. So if we are happy with the solution the group will come with, then in a few years we might try to perform a few changes in Capella to be more closely aligned. So I just mentioned that we have imports and exports from Capella to SysML and in the opposite direction, but it's not necessarily what interests us the most. What interests us the most is some kind of API standardization, so that the tools that are meant to interoperate with SysML tools, our goal would be to be able to plug Capella instead of a SysML tool and have basically the same features. Because we've seen in several occasions, for example, with safety architects and so on, that tools that had plugin for SysML, really it was easy to develop the same thing for Capella, because once again, there are a lot of equivalences and similarities between SysML and Capella. So to finish this webinar, there is a web page to summarize all this, so the mapping of all the diagrams. So I invite you to connect to the Capella website, and you will see a link there showing basically what I presented in this webinar based on the camera. In addition to the questions that you will have right now, we will be happy to use the Capella forum or the LinkedIn discussion group or whatever mean to keep on discussing all this. And maybe if you feel you need to correct some of the things that we said about SysML or to change our understanding, then you're welcome. So I guess this is it for what I had to say, and now I'm open to questions.